Today, in 20 minutes of physics, we will continue our story about the kinematics. You know that the motion is a change of position of an object in space over time. Suppose that the point was firstly in position A, and then it moved to the position B. Let us connect the points A and B. But to make it clear where the body moved from, we need to show a directional segment, not just a simple segment. And what is a directional segment called? We call a directional segment vector. And let us call this vector S. This vector is called the displacement vector. The displacement vector of a material point or an object is a vector that connects an old position to a new one. If the body was at point A and it is now at point B, does this mean that the point moved in a straight line? Not, absolutely not. Let's say the body moves like this, in a very strange way. The starting position is A, and the ending position is B. The line along which the body moves is called a trajectory. The length of a point track is called a distance. The displacement is a vector, and the distance is always a positive number. How do you think? Is the modulus of a displacement vector is related to the distance? No. Depending on the trajectory of the body, the distance can be larger or smaller than the modulus of the displacement vector. And in which case the distance is minimal? The distance will be minimal when the trajectory coincides with the displacement vector. If the body moves in a straight line, the distance is equal to the modulus of the displacement vector. In all other cases, the distance is bigger. In other words, the modulus of the displacement vector is always less or equal to the distance. Now let's talk about the basic operations on vector. Well, you already know the vector quantities. You know, for example, that a force is a vector. A force has a direction and a numerical value. Unlike scalar quantities such as mass, volume, density, time, which are defined only by a number, the vector quantity requires, in addition, the information about the direction. In physics, in general, there are more scalar quantities than vector quantities. But vectors are more informative. So we will have to learn to perform operations with vectors in such a way that they are as familiar as operations with scalars. The first operation we will learn is the multiplication of a vector by a scalar. What we are talking about can be used not only for one specific vector. These operations are general, these rules are general, and can be used for all vectors. Well, let's note some vector by a letter A. It will be some vector. And an arrow about it means that we are talking about a vector quantity. The modulus of a vector also has its own definition. It can be denoted as follows. But this notation is very complicated, and the physicists do not use it much. We use a simplified notation. We just write a letter without the vector sign. And the letter without a vector sign means the modulus of the vector. So, we want to multiply a vector A by a scalar. Suppose the vector B is equal to the product of the number k and the vector A. To know what the vector B will be, we need to specify its modulus and the direction. If the vector B is a product of the scalar k and the vector A, then the modulus of the vector B will be equal to the product of the modulus of the vector A and the scalar k. But the modulus is never negative. The modulus of the vector is always positive, and k in principle can be negative. So here we have to put an absolute value of k. We need to take an absolute value of k. So the modulus is defined by this rule. And the direction of the vector will be defined like this. If the vector B is codirectional with the vector A, so we note it by two arrows with the same direction, vector B will be codirectional to the vector A if scalar k is positive. The vector B will be opposite to the vector A, or will have the opposite direction if k is negative. To show that we have an opposite direction, we note two arrows. We take two arrows in opposite direction. And can k be equal to 0? Why not? Then b will be equal to null vector. What is null vector? It is a vector whose modulus is 0. And what is the direction of the null vector? Its direction is undefined. But we are not allowed to write down the vector b equal to some scalar. It will not be correct. Because here we have a vector to the left. Here we must put a vector to the right too. That's how the concept of a null vector was born. And this is how the modulus and direction of the vector b were defined. Now let's take some examples. The vectors can be represented with arrows. Let's show some arrow. The direction of the arrow indicates the direction of the vector, and the length of the arrow at certain scale indicates its modulus. And let's take an example like this. Let the vector b equal 3 vectors a, and vector d equal to minus 2 vectors a. And the last one, let's say the vector e equals to minus the vector a. And let's construct all these vectors. Well, to do this, to construct all these vectors, we must first construct the vector a. And let's agree that the vector a has a direction to the right and its length is equal to two squares of your notebook. Now, what will be the direction of the vector b? In the same direction as vector a, since here 3 is a positive number. And the modulus of the vector b, it will be 6 squares. So the vector b will look like this. To the same direction as a, and the modulus is equal to 6 squares. And what will be the vector d? It will be directed against it will have the direction in the opposite side as above vector a. It will be opposite to the vector a, which is in our case to the left, and its modulus will be 4 squares. 2 times 2, 4. Let's construct this vector. The direction to the left and modulus 4 squares. And finally, the vector e. It will be identical to the vector a, but it will be directed to the, in our case, to the left, in the opposite direction. And the modulus of the vector e will be the same as a modulus of the vector a. Because here, minus, it means -1. Okay, so we have the modulus which is equal to, which is the same as the modulus of the vector a. The next operation that we will consider is the addition of two vectors. Suppose we need to add two vectors. We note one vector by a and another by b. So let's show the first vector a and the second one b. So a, and here it will be b. And we need to find the vector c, which will be the sum of the vectors a and b. Let's note c is equal a plus b. There are two rules to add vector, for adding vectors. These rules are based on the fact that a vector is defined by its direction and its modulus. And if I move a vector parallel to itself, it means it remains the same, it remains equal to itself. Because if I move this vector, the modulus does not change and the direction does not change. So the vector remains the same. And these vectors are said to be free. And let's move the vectors a and b parallel to themselves, so it will be much more convenient to work with them. And let's start with the vector a. And now let's put the origin of the vector b. Let's superpose the origin of the vector b with the end point of the vector a. We'll move vector b parallel to itself so that its origin overlaps with the end point of the vector a. And now let's form a triangle. It will be our vector c. Well, we have found this vector c, and now let's think about the direction of this vector. You don't need to know any mass to do it. What you can do, imagine that A and B, there are two movements. Suppose a hiker has traveled along the vector A and then it turned right and traveled a displacement equal to vector B. And if we connect the starting point and the end point, we will get the resulting vector C. This will be the vector C. So we know the direction of this resulting vector. And the direction will be from the origin of the vector A to the end point of the vector B. And this is the so-called triangle rule. So, to add vectors by using the triangle rule, we need to superpose the end point of the vector A with the origin point of the vector B. And the sum vector will be obtained if you draw a vector from the beginning, from the origin of a vector A to the end point of the vector B. By the way, the vectors can be added in any order. We can add vector B to the vector A. Suppose that we have vector E, which is equal to B plus A. And let's find this vector E. So we will start with the vector B, and now by using the parallel transfer, we add the vector A to the vector B. To get the vector E, we need to draw a vector from the origin of the first vector to the end of the second vector. So origin of the first vector is the origin of the vector B, and endpoint of the second vector is the endpoint of A. So let's connect and we will obtain the vector E. We see that vector E and C have both the same length and direction. That is, the sum of these two vectors remains unchanged by the change in the place of the vectors. That's all for today. Tomorrow we will learn how to add the vectors by another way, by the parallelogram rule. Have a nice evening. See you tomorrow.